So let's take a look at two problems in Achieve section 3.9, numbers 1 and 2. They have some basic rules. The first one here in section 3.9 deals with the derivative of the natural log function. So the derivative of the natural log function we derived right in the lecture videos to be 1 over x. You should review all those derivatives of the general logarithmic and general exponential functions in that lecture video. Okay, so when we take the derivative with respect to x of this expression, you'll notice this first expression has a product, 6x times the natural log of x. So I'm going to have to use the product rule on that. And then negative 4x, that's pretty easy. So the product rule on this first part, I'm going to just treat it as 6x times the natural log of x. Take the derivative of 6x times the natural log of x plus 6x times the derivative of the natural log of x minus the derivative of 4x. Well, obviously the derivative of 4x is just 4. The derivative of 6x is 6. And as we just said, the derivative of natural log function is 1 over x. Pretty easy, clean it up, 6 times the natural log of x. Here you got to be careful, 6x times 1 over x. X divided by x is 1. I'm just left with 6. Minus 4. 6 minus 4 simplifies to 2. And there's our answer, 6 times the natural log of x plus 2. Number 2 deals with the derivative of the general exponential function, right? The derivative with respect to x of a to the x is the natural log of a times a to the x. Notice this works for e to the x since the natural log of e is equal to 1. In the generalized rule here, which is the chain rule, if I have the derivative with respect to x of a to the u, where u is a function of x, it's the chain rule. Derivative of the outer function, again, is the natural log of a times a to the u, right? Which is what we get from this rule up here, but then times what? Chain rule derivative of the inner function. We use the chain rule so much, right? So, you should be really comfortable with this at this point. And this is the one that we're going to be using in this particular case, because here I've got the a in this case is 7, and my u, my inner function, is x to the 8th power. So the derivative is the derivative of the outer function, natural log of 7. 7 is the base, right? And that's the natural log of the base, a, times 7 to the u, where u is x to the 8th, times the derivative with respect to x of u, which is x to the 8th. What's the derivative of x to the 8th? That's power rule. Bring the 8 down. Subtract 1 from the exponent, we get 8x to the 7th. So multiplying this together, I can bring this 8x to the 7th in front times 7 to the x to the 8th power, right, times the natural log of 7. Now, this is the way Achieve wants it. I usually put the parentheses all the way around this. And the reason I do that is so that it doesn't get included with this base 7. It's not all of this raised to this power. It's just 7 raised to this power. I usually write it this way, 8 times the natural log of 7, because the natural log of 7 is just a number. This is like the numerical coefficient. You could take your calculator and do 8 times natural log of 7, you get a number. Times what? X to the 7th times 7 to the x to the 8th power. But this is what Achieve, I think, wants. I'm not sure if it will accept this one as well. And again, they write ln and then in parentheses 7, because this is the log function. This is the natural log of 7. Remember, a logarithm is an exponent. So this would be the natural log of 7 is basically what the exponent on e needed to get 7. E to some power is 7. That's what this number is. Okay, so at any rate, hope this makes sense and helps with these first two problems in section 3.9.